Hello everyone, in this video we're going to explore topic 9.2 second derivatives of parametric equations. Alright, so we're going to use this theorem to find the higher order derivatives parametrically. D squared y over ds squared, this is actually the second derivative. So you're going to take derivative of dy over ds with respect to s. Then I'm going to divide the top bottom by dt, right? So it turns out to be derivative of dy over ds with respect to t over derivative of s with respect to t, right? Now similarly, you're going to take the third derivative. It's the same thing as you're going to take the first derivative of the second derivative right here, right? Now let's take a look at the first example. Finding the second derivative of a parametric equations. Find and simplify d squared y over ds squared for each of the following, right? So given the function s of t equals e to the t and y of t equals t times e raised to the negative t, right? First, you need to take derivative dy over ds, right? It's the same thing as dy over dt divided by ds over dt, right? And then you're going to take the derivative of this one with respect to t, right? So you're going to use product rule, right? Use times v derivative. It's going to be u prime v plus v prime u, right? So this guy turns out to be e to the negative t minus t times e to the negative t, right? Over ds over dt is going to be e to the t, right? Alright, now I'm going to bring this guy to the top. So this guy turns out to be e to the negative 2t minus t times e to the negative 2t, right? I'm going to factor e to the negative 2t out. So it's going to be 1 minus t, right? Now I'm going to take the second derivative, which is the first derivative of this guy, right? So it's going to be d squared y over ds squared is d over dt dy over ds, right? Over ds over dt, right? The formula right here. Alright, so you're going to take the derivative of this guy with respect to t, right? I'm going to use the product rule right here, right? So it turns out to be negative 2 e to the negative 2t times 1 minus t, right? Plus e to the negative 2t times negative 1, right? Derivative of this one equals negative 1 over derivative of this guy with respect to t. So it can be e to the t, right? Now I'm going to simplify the numerator, right? So negative 1 times this one equals negative e to the negative 2t, right? So I'm going to factor e to the negative 2t out. It's going to be negative 2, and then I distribute negative 2 to this guy right here, right? So it could be plus 2t, right? Minus 1 over e to the t, right? So this guy turns out to be e to the negative 2t times 2t minus 3 over e to the t, right? I bring this guy down. So this guy turns out to be 2t minus 3 over e to the 3t. This one is the final answer, right? Now, question B, you're going to do exactly the same thing, right? So you have dy over ds equals dy over dt over ds over dt, right? So dy over dt equals this one right here. You're going to use psi u prime. It's going to be u prime times cosine u, right? So u in this situation is 2t, right? So it could be 2 cosine 2t, right? Over ds over dt, which means negative sine t, right? Now, d square y over ds square is, we're going to use this formula right here, right? So we're going to take the derivative of this one with respect to t, right? So we're going to use the formula u over v prime equals u prime v minus v prime u over v squared, right? So this guy turns out to be u prime, which means you're going to use the cosine u prime. It's going to be u prime times sine u. Don't forget the negative side right here. So this guy turns out to be negative 4 sine 2t, right? Because you're going to bring 2 to the front and then don't forget negative side, right? Times v, which means times negative sine t right here, right? Minus v prime, derivative of this one equals cosine, right? So minus, and you have negative side here, becomes positive cosine t times u, which means times 2 cosine 2t, right? Over v squared, which means sine square t, right? And I'm gonna put the equal sign right here. This one is the main fraction, right? ds over dt, right? So s of t is right here, right? So it's gonna be negative sine t, right? Now I'm gonna simplify this one further. So this guy turns out to be negative right here becomes positive, right? So I have 4 sine t sine 2t, right? This guy turns out to be plus 2 cosine t cosine 2t, right? I'm going to combine this guy and this guy, right? So this guy turns out to be negative sine cube of t, right? This one is the final answer. Now let's move on to segment number 2. Finding the slope and concavity, right? The slope, which means the first derivative, right? Concavity, which means the second derivative, right? Now, when the second derivative is positive, the function is concave up, right? When the second derivative less than 0, the function is concave down, right? So we have dy over ds equals dy over dt over ds over dt, right? So you're going to take the derivative of this one with respect to t, right? So this guy turns out to be 1/2 t squared, right? Over the derivative of this one with respect to t is going to be 1 over 2 square root of t, right? Alright, so this guy turns out to be t squared over 2 times 2 square root of t, right? So this guy turns out to be t power 3/2, right? Now, the second derivative, d square of y over ds squared. We're gonna apply the formula right here again, right? So we're gonna take the first derivative of this one right here. It turns out to be 3.5 t raised to the 1/2, right? Over ds over dt, which means 1 over 2 root t, right? So this guy turns out to be 3.5 square root of t times 2 square root of t, right? So 2 and 2 cancel out, it's going to be 3t, right? Now, since we given the point right here, this is actually s and y, right? But s equals this one right here, right? So we have square root of t equals 2, right? This one right here actually equals this one right here. Square both sides of t equals 4, right? Now we need to evaluate the slope, which means dy over ds when t equals 4, right? dy over ds is actually right here, right? So it's going to be 4 raised to the 3.5, right? It's going to be 8. Now, d squared of y over ds squared when t equals 4 is going to be right here. So it's going to be 3 times 4 equals 12, right? This one greater than 0. The function is concave up, right? Now let's move on to example number 3. We're going to use the fundamental theorem of calculus with parametric equations. Alright, a particle moving along a curve in the xy plane is s position s of t square of t at time t, where ds over dt equals natural log of t plus 1 and dy over dt equals sine of e to the negative t squared for t greater than or equal to 0 at time t equals 1. The particles is at position 2 and 5. Find the slope of the tangent line to the curve at position 2 and 5. Alright, so when we talk about the slope of the tangent line, we talk about the first derivative, right? So we have dy over ds is dy over dt divided by ds over dt, right? dy over dt is this guy right here, sine of e to the negative t squared over ds over dt is given by this one, natural log of t plus 1, right? Then we need to calculate dy over ds at t equals 1, right? So we substitute 1 for t into this one, right? So we have a sine of e to the negative 1 square, which is negative 1, right? Over natural log of 2, right? Now we're going to use the calculator to calculate this one. So we're going to add calculator. Now sine of e to the negative 1, which is the inverse, right? So you're going to hit the fraction right here first. And hit trig right here, the side right here. E to the negative 1, right? So it could be e right here to the negative 1 over natural log of 2, right? So it's going to be control e to the s right here, put 2, hit enter. Alright, so you're going to convert this one to decimal. So you're going to press menu, number, convert to decimal, and press enter. The answer is 0.543, right? Now let's move on to question B. Find the x-coordinate of the position of the particle at time t equals 3, which means s of 3 equals how much, right? Now given t equals 1, you have the coordinate points right here. Now we need to use fundamental theorem of calculus. So we have s of 3 equals s of 1, right? Plus the integral from 1 to 3, right? This one right here, right? Because we talk about the x coordinates, so we're going to take anti-derivative of the first derivative right here, right? So it could be natural log of 1 plus t dt, right? So this guy turns out to be s of 1 equals 2 right here, right? So it could be 2 plus, now we're going to bring up the calculator. You're going to press menu, calculus, integral from 1 to 3, right? And then you're going to input this function right here, right? So it could be natural log of 1 plus t dt, right? And press enter. Convert this one to decimal. Press menu, number, convert to decimal, press enter. The answer is 2.158. Alright, so total is going to be 4.158, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings, as the chemicals they take us higher. The night's young, it has just begun, as she puts her hand